Today we're going to look at electron configuration. Electron configuration is just the address of the electrons in an atom, and it is very important that we know where those electrons are. So we're going to look at kind of the overall format. If you look at this long list of letters and numbers, this is just kind of like your cheat sheet, your base code that we go to look at. This is the order that they're going to follow. So if you notice, we've got the numbers 1, 2, 3, and 4. So and it keeps going 5, 6. It would go up to 7. That represents the row that the electrons are on, or the period. If you remember, we call the rows periods and then the columns groups. We're going to be kind of focusing on the periods today. So the number is the energy level or the period that is on the periodic table. The S, P, D, and F are these different sublevels, and they are represented on the periodic table. And then you've got the exponents, and the exponents are the number of electrons that are in that particular level. So if we just take, for example, we're going to do 2p6. If you see this, it means that in the second energy level, in the p sublevel, there are 6 electrons. And you might see it a little bit different. There might only be, let's say, 3 electrons in this sublevel, but it's never going to go above 6. If you have more than 6 electrons, they're going to go to the next energy level. So let's just kind of look at an example. So remember that the number of protons equals the number of electrons. So we have the atomic number here on the periodic table, so we know the number of electrons. So let's just start with the easiest atom. We have hydrogen. Hydrogen has 1 electron. So its electron configuration is just 1s1. It means that on the first row in the S sublevel there is 1 electron. That's the only place it can go. It's always going to fill the lowest energy level first. And this 1s is the lowest energy level, and then going up, now 4f14, it keeps going. We're not going to go that far. And so I did not write any more on here. At another point I can give you the rest of the code, but for right now, for today, that is all that we need to know. So we've got 1s1. Now if we go to the next one, which is helium, and you notice that I wrote helium in this little spot, and it's actually over here. But helium is in the S block instead of over here in the P block, and you'll kind of understand this later, why the periodic table looks the way it does, why it's not drawn here to begin with. But for what we're doing today, we're going to just kind of think of helium as being right here. So helium has 2 electrons because it has an atomic number of 2, so its electron configuration is 1s2, which means there are 2 electrons in the 1s sublevel. Okay? So if we go to the next atom on the periodic table, it is lithium. Lithium has 3 electrons. Now I still have to write what's going on the first energy level. So we've got 1s2. Notice that's the first row. Then we go to the second row, and it's 2s1. Notice that my exponents add up to 3. So that is the number of electrons in the lithium atom. Okay? So basically you're following a pattern. You kind of have to write what's gone on before, and then you just kind of keep adding to it. So for beryllium, we're going to copy what we already did, but instead of putting 2s1, we're going to put 2s2. So when you write this, it's the total number of electrons that are in that energy level. So we don't want to have to write it out a million times. We just have to kind of write out how many are in each sublevel. So there's beryllium. Now let's skip a few and let's do carbon. So carbon has an atomic number of 6, which means it has 6 electrons. So I can just kind of copy 1s2, 2s2. Now we're getting to something a little bit different. Notice that we have all this empty space. But we get here, and this is the P block. And you also notice up here, do you see how it goes to 2P? We're still on the second row. Now I don't want to put 2P6, I want to put 2P and then 1, 2, 2P2. Notice that it adds up to 2, 4, 6. That is the electron configuration for carbon. Now if we move on and did magnesium, which has an atomic number of 12, we end up with 1s2, 2s2. Now we're going to go all the way through the P block, which is 2P6, and then we're going to go, and it's going to be 3s2. And if you get confused, look up here, and you can kind of see, okay, after 2P6 comes 3s2, or you can look on your periodic table and just follow as you go. So we've got the first row, 1s2, the second row, 2s2, 2p6, the third row, 3s2. Let's say we have chlorine. So I'm going to copy exactly what I have for magnesium, 1s2, 2s2, 2p6, 3s2, and then we've got 3p5. And notice that it's going to add up to 17. 10 plus 7 is 17. That is the electron configuration for chlorine. Now, you might think, oh my goodness, this can get really long. There is a shortcut method, but I want to show you one more, and then I will kind of let you in on the shortcut. But you're going to have to know how to do both of them. I just won't give you any really large atoms to write the electron configuration for all the way out. I'll show you the shortcut method. Now, the D block gets a little bit more complicated. If you look up here, notice that after 4s, you go to 3D instead of 4D. So 3D is actually in the third energy level, but it comes after 4s. And I know that is confusing, but if you will just kind of follow the rules that I gave you, and you will have this to look at. You can actually take a periodic table and make all these notes on it, and you can use it on the test. But eventually you'll just kind of get to where you will understand it, and it really does make sense. I've kind of written on here the different sublevels. So this is the S sublevel, this is the P, this is the D, and the bottom one is the F. Now, let's just do manganese. All right, I'm going to do it down here so I have a little bit more space for this one since it's kind of long. All right, so now manganese has a total of 25 electrons. I'm just going to start off the way that I do it, is that I'm going to look at the first row. So notice that the first row is 1s2. Then the second row is 2s2, 2p6, and then we've got 3s2, 3p6. So that's really easy. I've gone through the first three rows. They're very straightforward, very simple. Now, when we get to the fourth row, it gets a little bit confusing. Now, we're going to do 4s2 because we're on the fourth row. Now, notice that I have a 3 written right here, and then you see where I have n minus 1. The D block goes down after 4s2, and if you look up here, you're going to go to 3D. So we're going to do 3D. So 1, 2, 3, 4, 5. 3D5. And then if you add it up, we should get 25, 10, 25. Okay? All right, so we're going to stop right here, and I'm going to let you practice with that. I do not want to completely overwhelm you, so practice a few examples like this, and on the second video, I will show you how to do the shorthand.